Hi, I'm Keenan Casey for TouchPlus.com. Welcome to this course on Machine Learning Distilled. In this course, we're going to be looking at machine learning, but in a very compressed way. We're going to be asking three basic questions. What is machine learning? Why does anybody want to do it? And how is it done? My goal is to take a subject that's very large and complex and boil it down so that it's short and understandable. After taking this course, you'll understand the basics of machine learning, a little bit of how important algorithms work, and some of the fundamental considerations to keep in mind when you're working on a machine learning project. First, in order to get a feel for what machine learning is about, I'd like to just take a look at this word cloud that I created from the Wikipedia entry on machine learning. You can see the words that are more common are larger. What you see from this is some of the really important words and ideas associated with machine learning. What we see is that machine learning is very much about data. We're finding data, we're finding examples, and hopefully we are extracting some knowledge from them. Other important words you see are representation. So machine learning is going to have a lot to do with how do we represent this knowledge, this information, this model that we're extracting from the data. In order to do this, we're going to use some algorithms, some computational methods to analyze data, find patterns, and hopefully achieve learning. Before we start anything that is time-consuming, I think it's important to ask why. Why should I spend my time studying this material? And I've got three brief answers as to why I think it's worth your time to study machine learning. First of all, machine learning is very much precipitated by the explosion of data that's happened of late. As we're collecting more and more data on more and more things, there's often value in digging into that data and figuring out what are some underlying things that are going on. What are some important pieces of information that could help me do my job better, that could help me save money, that could help me help people if I can understand what's going on in the data. So big data has made machine learning much more important. Secondly, machine learning is about prediction. Machine learning allows us to extract patterns that allow us to take some input and predict the output. So if you can predict the future, you're in a good place. Usually being able to predict the future is valuable. And thirdly, machine learning is really useful because it allows us to do discovery. It allows us to discover new relationships, new connections within a large set of data that perhaps are unintuitive, that we didn't understand before. So 3 reasons to study machine learning. We've got this explosion of data, and machine learning allows us to do prediction in data and discovery of knowledge within data. What is machine learning? Well, this is a definition that Arthur Samuel wrote a long time ago. He said that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. I think this is interesting because we all have some conception of learning because we've all done that since we were babies. As developers, we have some understanding of what it means to program something. What machine learning does is it allows us to find new relationships such that a computer program is automatically, implicitly, sort of programming itself. Machine learning is allowing computers to encode information into a program as opposed to forcing a human being to do it. This diagram shows how human learning works. Notice that we've got the person. There's some inputs to the person does some processing with those inputs and produces some outputs. This could be anything, like as simple as I see a hot pot on the stove. Do I touch it or not? If I touch it, I'm probably going to learn something. So this big arrow in the middle is the learning experience. After the learning experience, I have the same inputs. I have a different processing and perhaps different outputs. This is what machine learning is as well. We've got some inputs to a computer system, it does some processing, and produces some outputs. If we can actually cause the machine to learn, then given those same inputs, the machine should process differently and produce different outputs after learning has taken place. So this is our goal in machine learning, to help the machine produce better outputs, do better processing given the inputs. Let's take a look at this process in a little bit more depth. The process begins with data, also called training examples. Machine learning relies on there being a good sized set of data, which is examples of how some system operates, some inputs and some outputs. What's really going on here, though, is that we are going to use this data to try to model the real process that's going on. And that process or relationship is also called the target function. Typically, then, we're going to model the target function using this data. We will create possibly many models or representations that represent the mapping from inputs to outputs for our information. The learning algorithm will then take a set of data and a set of models and try to find one model, the final model or the final hypothesis, that best explains, that best maps inputs to outputs. That is, the final model will best model the target function. What goes on inside this learning algorithm? We're typically going to use an iterative process where we start with a model, we take that model and evaluate it. After evaluating it, we will have some results that give us some insight into the error of the model or how good the model works on the training data. We'll use those results to optimize our model, to tweak it in some way so that hopefully we get a new model, which after being evaluated produces better results. And we'll continue this cycle until we get a model that is acceptable to us, and that'll be our final model. So this is a bird's eye view of the machine learning process. Next, let's consider three components of machine learning. The first component of machine learning is representation. What this means is we have to decide how to represent our model. That may be mathematically or algorithmically. What's the representation of the model? Secondly, we're going to have to define how we evaluate our model. That is, how do we determine if the model is good or bad? And thirdly, we need an optimization method. That is, a way to search among the many models and choose the model that's best, that really produces the best results, and that's the one we'd like to use. By combining different options for these three components, we can achieve lots of different machine learning systems. For example, in the representation, we see lots of examples. Many of these we'll look at in this course: the k-nearest neighbor, or the naive Bayes, or the linear regression, neural networks, or support vector machines. In terms of evaluation, they've got lots of ways to evaluate a model in terms of its accuracy or error rate, its cost or margin. And lastly, in terms of optimization, there are a lot of ways we can do search or different kinds of optimization programming to solve systems so that we get the best performance. Machine learning really has three fundamental components. First of all, gotta have data. If you don't have data, machine learning is not for you. It is mandatory. No data, no dice. Number two, machine learning works when there is a pattern. A pattern actually exists. There's some underlying pattern. We may not be able to put our finger on it. For example, if we wanted to create a machine learning model for a random number generator, we could create models, but they would be useless in predicting the output because the output of the random number generator is always random. There's no real underlying pattern. The underlying function is unpredictable. And thirdly, complexity. Machine learning is going to work best when there is a pattern that's complex in the data. While not required, machine learning is really worth all the effort if there's not a simple mathematical model that captures the relationship in the data. Machine learning is going to allow us to find patterns that are difficult to represent with simple mathematics, and that's where machine learning is really going to shine, when there's some complexity to the model. This will be our outline for the course. We'll first look at supervised learning. Next, we'll look at unsupervised learning. And lastly, we'll talk about some theoretical and practical issues. If these topics sound interesting to you, please check out the rest of the lessons in this course on Machine Learning Distilled. I'm Keenan Casey for tutsplus.com. Thanks for watching.